Hi guys, my name is Lavkaran Singh and today we are going to see what is chi-square. So chi-square was introduced by Carl Pearson to distinguish whether an observed set of frequencies differs from an specified frequency distribution. So chi-square uses frequency data to generate a statistics. So chi-square is commonly used for testing independence and goodness of fit. So testing independence determines whether two or more observations across two populations are dependent on each other, or in testing for goodness of fit, we determine if an observed frequency distribution matches a theoretical frequency distribution. So chi-square is of two types. One is parametric and other is non-parametric. In parametric, we use it to test for comparing variance, and non-parametric we use for testing independence and test for goodness of fit. So in most of the books we use only non-parametric. We don't use parametric often. These are some of the conditions for the application of chi-square test. So first is observation. Observation recorded and collected are collected on random basis. All items in the sample must be independent. Like for example, so for example, if we are selecting this sample, and for that example we have to select this sample. So this must not be happen, like both sample must be independent from each other. So third condition is no group should contain very few items, say less than 10 items, and most of the statisticians say like we can also use only like 5 items as minimum items. And fourth condition is total number of items should be large, say at least 50. Moving further, formula to solve the chi-square is sigma observed frequency minus expected frequency whole square divided by expected frequency. So for example, we have one question over here. So a personal director wants to test the perception of fairness of three methods of performance evaluation of 180 employees. So 63 employees rated method 1 as fair, 45 employees rated method 2 as fair, and 72 employees rated method 3 as fair. And we have 0.05 as a level of significance, and we have to determine whether there is a difference in perception or not. So as our data is given over here, so observed frequencies are 63, 45 and 72, and we can find expected frequency by, just a second, by dividing 180 by 3. So we found 180 from here. 180 is the total of all the observed frequencies. So it will be, so it's 180, and we can find expected frequency by dividing 180 with 3 because we had 3 observed frequencies, and then we have to minus observed frequency with the expected frequency. So 63 minus 60 is equal to 3, 45 minus 60 is equal to minus 15, and 72 minus 60 is equal to 12. And after that we will do the square of all the answers we got. So square of 3 will be 9, square of 15 will be 225, and square of 12 will be 144. And after that we will use our formula, like main formula, this one, to solve to get our answer. So So after that we will divide 9 by 60, we will get 0.15, and we will divide 225 by 16, we will get 3.75, and dividing 144 by 60, we will get 2.4, and the sum total will be, the final answer will be 6.3. We will get our final answer as 6.3. And after that our null hypothesis was like all the conditions same, and our other hypothesis is like at least one is different. So our answer was 6.3, and our critical value is 5.991, and as our answer is 6.3, and that lies in this area, like greater than our critical value, so we will reject the null hypothesis. And here is our decision, like we will reject the null hypothesis, and our conclusion is at least one proportion is different. Moving further, we will test for checking independence, and for checking independence we have to calculate expected frequency with the different formula. The formula is like row total multiplied by column total and divided by grand total. So our row total is this one, and our sorry, I think I was wrong. So our row total is this, and our column total is this one. So moving further, these are our conditions. We will reject the hypothesis if there is no difference between Democratic and Republic in their opinion on the gun control issue, and other is there is an association between responses to gun control and the party membership in the population. So these are our all the frequencies, like frequency, observed frequencies, and to solve for our expected frequency we have to use this formula, like we already saw that formula, row total multiplied by column total and divided by grand total. And here is an example of using that formula. So row total, like for example we are solving this one, so row total is 40 multiplied by column total, so column total is this one, and divided by grand total, that is 90. So to solve our df, like degree of freedom, we will use formula like number of rows minus 1 and number of columns minus 1. Our number of rows was 2 and number of columns was 3, so our answer will be 2. And after using the same formula again, we can find our answer, and that will be 11.03. And we can find that formula like using all of these given data and adding them all together. For example, like this is our observed frequency and this is our expected frequency. So let me remove this all the mess. So 10, we will use that formula like 10 minus 13.9 divided by 13.9 and adding them all together by like using the same method, and then we can get 11.03. So let me add some more data in the video. Let me pause the video. So here we go, I just add some more data over here so you guys can use calculator and you guys can check data and solve it, and we will get 11.03. Like using calculator will be helpful for you. So as we get 11.03, and sorry for my bad drawings. So our critical value was over here, and we got 11.03, so that is lying in this area. So our decision will be null hypothesis is rejected, and conclusion will be Democrats and Republicans differ significantly in their opinion on gun control issue. So I hope you guys found this video helpful, and thank you.